Hey guys, welcome back everybody. Hope you all are doing great. Guys, I have seen most of the beginner network engineer has a common question in their mind. And question is this. What is the difference between hub spoke and full mesh topology? Tell me the scenario where we are using full mesh topology in the real time in the production network, like to connect multiple branches. Or tell me the scenario where we are using hub and spoke topology in the real time in the production network. And guys, lots of my subscribers, my followers are asking this question to me. Sir, where we are using hub and spoke, where we are using full mesh, which one is the most popular, more popular, right? So as a network engineer, I will work on which type of topology, on hub and spoke topology or on full mesh topology. So if you are also among them, if you are also not clear with hub spoke and full mesh topology, then guys, this video is for you. In this video today, we are going to understand the scenarios where we are using hub and spoke topology, and guys, the scenario where we are using full mesh topology. According to my experience, I will also tell you which one is the most popular, more popular, right? Hub and spoke or full mesh. But for now, both are popular. At the end of this video, I will tell you which one is more popular. But guys, for now, both are popular because see, which topology I should use in the real time, that depends on many factors like cost, reliability, performance. There are many factors, right? And the topology types also depends on these factors only, right? Which type of topology I will use in the real time, that depends on multiple factors. Now let's suppose you are going to connect few branch offices together. Let's say you are a network engineer in a company, XYZ company, and the XYZ company have headquarter in India, one branch in, let's say, Australia, and one branch is in New York, right? So you need to connect these three branches together, correct? Now you have two options. Either you can connect, you can design hub and spoke topology, or you can design full mesh topology. But see, if you will connect in full mesh topology, then you have to purchase lots of connection, right? I'm talking about the WAN connection, because in full mesh you are going to connect all branches together, right? Means India is connected with US is connected with Australia is connected with India. And like this, if you have thousand number of branches, so you need lots of connection, WAN connection, right? So you have to pay lots of money for WAN connection. But again, to connect thousand number of branches, I can use hub and spoke topology type. So in the hub and spoke topology type, you need one connection for one branch. Like to connect India branch to US, I need one connection. To connect India to Australia, I need one connection. So total number of connection is two to connect three branches. But in the full mesh, you need minimum three connection. In the same way, guys, like if we have multiple branches, thousand number of branches, so in that scenario, connection is going to be matter, right? But see, the another disadvantage of hub and spoke, here this is one advantage of hub and spoke topology, because we are going to purchase very less number of connection, right? We have very less WAN connection in hub and spoke topology. But see the redundancy, we don't have redundancy here in hub and spoke topology. But in the full mesh topology, as all branches are connected together with each other, there is redundancy, right? If any one link will goes down, or if any one side will goes down, right, it will not impact on the entire network. But guys, in hub and spoke topology, if your hub router will goes down, then your entire network will goes down, right? So that's why which topology type I should use in real time depends on various factors, and let's understand those factors today in this video. Now without wasting our time, let's begin. See guys, on the screen, this is my topology. In my topology, I have three router 1, router 2, router 3. You can assume router 1 is in India, router 2 is in US, and order 3 is in let's say Australia, right? And these all branches are connected together with the help of internet, right? So here first option is I can configure hub and spoke, means I can form OSPF neighborship between router 1 and router 2 as well as between router 1 and router 3. But we will not form OSPF neighborship between router 2 and router 3. This is what hub and spoke topology. Hub and spoke topology means all spoke routers are connected with hub router, right? But again, for the redundancy, what you can do, you can add one more hub router here, right? Like hub 2 R4, and I can connect like this, right? Okay, so hub topology means all my branch offices are connected with main hub router. And guys, in the full mesh, my all branches are connected together with each other. Like here also we have connectivity, here also we have connectivity, here also we have connectivity. So in this scenario, I have 3 internet circuit between router 1 and router 2, as well as between router 2 and router 3, as well as between router 2 and router 1 and router 3, and router 2 and router 3. So we have 3 WAN connection. Now I can configure OSPF on all link or any routing protocol you can configure. Now see, router 1 have still two neighbor, router 2 have also 2 neighbor of OSPF, router 3 have also 2 neighbor of OSPF. But in hub and spoke, router 1 will have 2 neighbor, router 2 will have 1 neighbor, and router 3 will have also 1 neighbor. Means all branch offices will have only 1 OSPF neighbor. And if you have 1000 number of branches, so hub router will have 1000 number of neighbors. So guys, in hub and spoke, this is also one disadvantage. See, load on the hub router. Load on hub router is high, right? So which type of topology I should use? Before that, it should be clear to you like what is hub and what is full mesh. Hub and spoke and full mesh. So here you can see both hub, spoke and full mesh topology are used in real time, but it has their own use case. So we are going to understand the use case also, like which type of companies are going to use hub and spoke topology, which type of companies are going to use full mesh topology, right? So it depends on many factor, on the use case, advantage, disadvantage, and after that choice between them depends on many factors such as network size. As I told you, network size is also matter. Like if your network size is small, then hub and spoke is the best, right? But if your network size is large, then guys full mesh is the best, right? So network size, performance, cost, and redundancy needs. Done. So first of all, try to understand hub and spoke topology. Central control. In the hub and spoke topology, you have central control because all branch offices are going to communicate via hub router, right? So you can manage all branch offices from the hub router, right? So that's why we can say centralized control. We have centralized control in hub and spoke topology. One central hub router, that is R1, connects with multiple spoke routers like R2 and R3 in my scenario. Simplified management. As hub router is going to manage all branch offices, all branch offices are connected with hub router. Management is also easy. You can manage entire network from the hub router, right? So you can see easier to manage since all communication passes through the hub, right? Then guys, cost effective. As I told you, fewer links are required. This link means WAN link. I am talking about WAN link. Fewer links are required as compared to full mesh topology. So these are what characteristic of hub and spoke topology. Now see the advantage. Cost effective, require fewer connection, fewer WAN connection, reducing cost of WAN links and hardware. In the hub and spoke, you need only one WAN port. In the full mesh topology, maybe you need more than one WAN port. So more hardware is also required in case of full mesh topology, right? Then guys, simplified configuration. Easier to configure and manage since the hub is the central point of communication, right? As hub router is the central point for all branch offices, for the entire network, it is going to be very easy to configure it. And then scalability. Why scalability? See, in the hub and spoke, how easy it is to add a new branch, right? If I want to add a new branch in my existing network, I can add easily, right? So I can scale the network, I can increase the network according to future growth. So that's why scalability. For scalability also, hub and spoke is the best topology, right? So scalability means new spoke can be added easily without significant change in the existing network, right? So with the help of minor change, minor modification in configuration, we can add new branch offices. On the hub router, we need to add few commands and we need to configure one spoke router. That's it. Like this, I can add the new branch offices, so it is easy to scale the network, right? Scalability. Then guys, what is the disadvantage of hub and spoke topology? See, single point of failure. This is the biggest disadvantage of hub and spoke topology. Single point of failure means the hub becomes a critical point of failure. If hub router will goes down, then entire network will goes down, right? So we have here single point of failure. The hub become a critical point of failure. If the hub router goes down, all communication between spokes stops. We have another option, we can add more hub router, right? Like R1, R2. Let's say these two are hub router. And guys, now here I have branch offices, router 3, router 4, router 5, router 6. I can configure like this, right? Now I have backup. But still, see, if both hub will goes down, then all branches will goes down, right? All communication will goes down. So in the hub and spoke topology, we have single point of failure, right? Then guys, second disadvantage of hub and spoke is load on the hub router. As I told you, the load on the hub router is high because hub router is going to make communication possible between all branch offices, right? All branch offices users are able to communicate with each other with the help of hub router. Let's say if two branch offices want to communicate with each other, hub router have to participate, right? Because both branches will communicate via hub. So load on the hub router is high. The hub is handling large amount of traffic. So this is disadvantage of spoke hub and spoke topology. Now try to understand the use case where we are going to use hub and spoke topology, guys, in the real time in the production network. So see, for the small network, for a small to medium size networks, hub and spoke is the best topology type, right? So a small to medium size network often used in scenario where cost and simplicity are more important than redundancy and performance. So for you, for your organization, if cost and simplicity means easier management is more important than redundancy and performance, then you will use what? Hub and spoke topology. Like me, I am teaching. For me, performance doesn't matter, right? I don't have any critical data, critical server, critical application. I'm only teaching, right? I'm making videos for YouTube, I'm uploading it, providing live training to students. So requirement is all branches should be able to communicate with each other. They should be able to communicate with each other. Perform, I can manage the performance. If there is no redundancy, let's say if internet is not working, no problem, I can work after 1 hour, after 2 hour, right? So for those type of organization, for those type of companies, hub and spoke topology is suitable, right? So always keep in mind, a companies for which a company for which cost and simplicity is more important than performance and redundancy, they will use hub and spoke topology, right? Because hub and spoke topology is cost effective. Done. Is cost effective and simplicity. It's simple, easy to troubleshoot, manage. But here we have issue with redundancy and performance. So if you can manage redundancy and performance, then definitely you should use hub and spoke topology. Then remote offices, commonly used for connecting remote branch offices to a central corporate office. Let's say a large company, a large enterprises company need to add one branch offices somewhere. So what they can do, they can use hub and spoke topology, right? They can install one router at that branch, and then they can connect that router to the main office with the help of hub and spoke. That topology will consider as hub and spoke topology, right? So for a small organizations, for a small businesses, hub and spoke is good. For all the organizations, for all the organizations where simplicity and cost is more important than performance and redundancy, then guys, next type of topology, that is full mesh topology. So in full mesh, if I will talk about the full mesh topology, see, direct connectivity, all branch offices are directly connected with each other. So every router has a direct connection to every other router. So here we have what? High redundancy. If any branch offices or any link will goes down, right, it will not impact on the entire network. So we have high redundancy. Multiple path exist between any two point, providing high availability. Now let's suppose in my scenario, R1, R2, R3, all are connected through internet. Here we have one connection, here we have one connection, here we have one connection. So see, if this link will goes down, no problem, these two users, these two branch offices can still communicate with each other, right, via hub router. If this link will goes down, no problem, these user can communicate like this, right? So here we have what, guys? Redundancy, high redundancy. Multiple path exist between any two point. Between branch 1 and branch 2, we have multiple paths, right, providing high availability. Then advantage of full mesh topology. So advantage can be redundancy. First of all, we have high redundancy here, right? So this is the biggest advantage. Then guys, reliable, provide multiple path for data, ensuring high availability and fault tolerance, right? So full mesh topology is more reliable than hub and spoke topology. After that, performance. So performance is also high here, right, in full mesh topology, because not a single router is going to manage entire communication. Like in hub and spoke, one single router is managing entire communication. But here in full mesh, we have separated link, right? All branch offices are connected with each other. So performance, reduce latency. Latency means delay. Reduce delay, like R1, R2, R3. Guys, suppose here I have some user and here I have some user. If this user will communicate with this user via router number 1, then definitely there will be some latency, right, as compared to if this user will communicate to this user by using this path, then definitely we will have less latency, right? So that's why in full mesh topology, performance is high, reduce latency, since data can take the shortest path between routers without passing through a central hub. So in full mesh topology, a router can forward traffic through shortest path, right? But in hub and spoke topology, you have to forward data from the central hub always, right? Then guys, next advantage of full mesh topology is no single point of failure, right? So if any one branch will goes down, then also it will not impact on my entire network, right? Other branch users are still able to communicate with each other. So we don't have here single point of failure like hub and spoke. So any link or router fail has minimal impact on overall network connectivity. Like now what are the disadvantages of full mesh topology? First of all, high cost, right, as you need lots of WAN connection, right? So first disadvantage is high cost, because you have to pay monthly for the WAN connection, right? After that, required a large number of link, again WAN link, which increase the cost of WAN connections and hardware, right? So as I told you, hardware means maybe at the branch offices you need multiple WAN port. So WAN port is what? One kind of hardware. So you need more hardware, more WAN connection. Then complex management, more complex to configure, manage due to large number of connection and routing information, right? So if we have large number of connection, definitely we need to perform lots of routing there, right? So management is not easy that like hub and spoke in case of full mesh. Then the use case where we will use full mesh topology, large and mission critical network. In the large enterprises network, right, in the production network, we are going to use what, guys? This network topology type, full mesh network topology type. So if my network size is large, then full mesh. If network size is small, then hub and spoke. So large and mission critical network, right, for the critical servers like Netflix, YouTube. So SpiceJet need always what? Reliability. Air India, this company, Amazon, YouTube. So all mission critical networks will use full mesh topology, and large enterprises used in scenario where high availability, performance and redundancy are more important, are critical than cost, right, and management. If high availability, performance and redundancy is more important than cost and management, management can be complex, that is acceptable, but there should be redundancy, performance should be good, right? The server should be available every time 24/7. Then guys, you will use full mesh topology, right? So you can see the scenario where high availability, performance and redundancy are critical, such as data center or backbone network. So in the data center or backbone network, we will always use, we are still using actually full mesh topology. The second use case is organization with high traffic requirement, right? Suitable for organization where the cost of downtime is very high. Cost of downtime is very high and performance is a priority. So if performance is the priority, then definitely I will use what? Full mesh. Because in full mesh only, guys, we have what? A direct connection. If we have direct connection, then performance is going to be good, right? Because router can forward traffic from the shortest path, but in the hub and spoke you have only one path. Then which one is more popular? Which is more popular? So guys, hub and spoke more popular for a small to medium sized network and scenario where cost and simplicity are important. It's commonly used for connecting branch offices to a central corporate network due to its lower cost and easier management. But full mesh topology more popular in large enterprises network, data center, backbone network where redundancy, high availability, performance are critical. The cost and complexity are justified by the need for reliable and low latency. But guys, again, if you will ask me, Praful, which one is more popular according to you for the real time? So most of the time I have seen people are using hub and spoke topology. Hub and spoke is more popular than full mesh topology. And if you are a network engineer in a small company, right, where simplicity and cost is the priority, then you will work on hub and spoke topology. But if you are an engineer in large enterprises company, guys, where priority where performance, redundancy and availability is important, is critical, then you will use full mesh topology. So today in this video we have seen many factors for so guys, today we have seen many factors of hub and spoke topology as well as full mesh topology. Hope this video was helpful for you. If yes, then please hit on like button, guys. If you are new on the channel, then subscribe this channel. We will meet soon in next video. Till then, stay safe. Bye bye. That's all for today.